Hey gang, it's Will from Tested.
And it's Norm from Tested.
Norm and Chan, we're getting ready to go try the CV Oculus Rift.
That's it, this is it.
And the Oculus Touch.
Your Half Moon prototype. We're going to get in the demo. I'm going to interview Nate. We're going to talk to Palmer and then give you our impressions. Stay tuned.
The future.
All right, guys, you know, this is Nate Mitchell, VP of Product at Oculus, and he's holding basically the engineering sample of CV1, the Oculus Rift. This is so exciting, Nate. How are you feeling?
Super exciting time. We're really thrilled to finally be here at E3 2015 showing off the Oculus Rift, the consumer Rift that people are going to be getting their hands on in Q1 2016.
That's right. So, you know, I have a bunch of questions. Let's go right away. Let's start off with what people see on the inside. I know you guys have written blog posts about some of the tech specs and the minimum system requirements, but I want to know how this basically differs from Crescent Bay and some of the questions that we didn't get answered about the Crescent Bay prototype. First of all, the screens. These are two screens that are what resolution?
So it's 2160 by 1200 split over two eyes. And they are running at 90 frames a second for that full low persistence experience.
Right, and these are OLED screens, so they flicker at a high rate, so when you move your head, you don't get that blurring or judder. Now, the screens are interesting. We didn't know this, but in Crescent Bay, and I assume for here, they're oriented in the portrait orientation, not landscape. Is that correct?
I believe so, yes.
When you guys were designing the product, because the old had the first development kit and second development kit, with one screen, it was horizontal like this.
That's right.
What led you to that change, that transition, to do the two screen and that effect?
So two screens gives us a lot of different advantages. One of the biggest ones is that we can actually move the screens independently alongside the lenses, right? And so that allows us, what we've done in the consumer Rift is we've added an Ipd adjustment, which is actually disabled here, so it's not that good of a model. But that lets us move the lenses to really fit naturally your natural Ipd for the most visually comfortable experience. And we can actually do the screens moving as well to make it perfect. And
the screen and lens are moving together.
Exactly, and that's something you absolutely can't do with a single panel.
Now, that's something that Palmer actually demonstrated, I think, at the press conference when you had that sample. The slider on the bottom is to adjust the Ipd Interpupillary Distance.
Yes.
What is that range for people? I know people are all sorts of different.
Yeah, we're covering, I think, the 5th to 95th percentiles, basically. And, you know, the average male IPD for United States sort of like Army is, I think, 64 millimeters. And so I'm not exactly sure what the range is, but it's covering the wide, like most people that are going to be using the Rift.
Now, relating to the optics then, field of view is a question that a lot of people have. You guys said that for the consumer Rift, you want to reach at least that 100 degrees field of view. What is it for this?
What we're saying is that it is at least 150 degrees. It's more than 150, or I'm sorry, wow, not 150 degrees. It's wider than DK2, which is, DK2 we said was 100 degrees, so this is over 100 degree field of view. The challenge is really how you measure field of view. No, there's not really an agreed upon way to do it. So if you crank this in, you might be able to get slightly more than 100 degrees.
Closer to your eyes.
Closer to your eyes, exactly, because the closer your eyes are to the lenses, the bigger the field of view is going to be. If you put glasses in there, it's obviously not going to be 100 degrees, it's going to be less than that. So because there's no agreed upon way, we don't have an exact number. We're just saying right now it's more than 100 degrees. And you can expect that same sort of wide immersive field of view that people have come to know using the Rift in the consumer Rift.
In the engineering of that, is that a requirement of the optics that you guys are using, which I assume are the Fresnel lenses?
It's sort of a mix of the optics and the display technology that we've chosen. The actual size of the panels, the lenses that we're using, how much distortion we want. We sort of optimize all of these things to give the absolute best, most immersive VR experience.
Are the lenses angled?
I don't believe so. It's kind of hard because we actually are using Fresnel lenses as well, so they always kind of sit at an angle, but for the most part, they're where you expect them to be.
And let's explain what the Fresnel lenses do, because this is basically to eliminate that screen door effect. It's like a diffusion of that effect.
Yeah, absolutely. So the Fresnel lenses that we've designed here, they're custom Fresnel lenses, and they're really, optics is this massive game of compromises between clarity, between distortion, between sort of diffusion of light. With the Fresnel lenses that we've selected here, that we've designed here, specifically for the screens that we have in the Rift, we're really going for an absolutely stellar visual clarity. It has a lot of distortion, and the actual sweet spot in the optics is a little bit smaller than usual, but we're able to compensate for all that distortion in software, and the overall experience, I think, is better than anything you've seen before in Crescent Bay or DK2 or otherwise.
And so they are different from Crescent Bay. That was my next question. How does this differ, the optics and lens system. You said that the sweet spot, that means when you're looking directly forward your eyeball, that point is going to be more clear than looking off to the side.
Absolutely, absolutely. That's something that's always been true of almost any of the optics we've shown, because we want distortion there because it helps us get that wide field of view. These lenses are actually just slightly improved over the Crescent Bay optics. We basically took everything we learned from Crescent Bay and that prototype, and we've made some improvements both in our own lens design and in the manufacturing process over the last few months. So,
how do you guys feel about then, like NVIDIA, for example, and their drivers and their intermediate software optimizing the rendering in the middle, so the graphics on the side don't need to be rendered as in high fidelity?
are you talking about foveated rendering?
Yeah, not foveated rendering, but they have their middleware, which they announced for their graphics cards. Where, like, for example, you don't need to render all the detail on the
So
side.
I'm not familiar with that exact bit that NVIDIA is doing. We're working with NVIDIA and AMD on a lot of their different VR techniques and technology. We were actually just, chatting with them this week and last week, both at the press conference and then here at the show. Having them be really focused and invested in the VR space is super important to making sure that not only does the Rift just work and have a great experience right out of the box, but also that game developers and content developers have all the APIs and tools that they need to really drive the GPU in a way that VR requires and that normal computers aren't designed for.
Compatibility and performance, basically.
Exactly, in a big, big, big way.
Now let's talk about the physical design. It's really light. I know you have this semi-rigid side here. I think something that people didn't get from that press conference is that there's actually a mechanical spring in there. Can you talk about that design?
So basically, we have a spring in there. We want this to pull just a little bit, but we also, it'll spring back, right? And so it gives you the most optimal fit basically as quickly as possible if you are adjusting it. But the goal with our whole strap architecture here is that it's customizable. It lets you adjust the Rift to really fit you. And once you've done it once, basically, you're all set. But it does give you a little bit of tug, so you can kind of slip it on like a baseball cap and have it almost snap back into place.
And this Velcro adjustment is the initial adjustment for your glasses, for your head, and then
Exactly.
the spring is right there where you can just pull that over your head as you put it in.
Yep.
The material, also really interesting. It's this fabric material. How does that help for breathability, for the weight, the fogging, all of that?
I mean, the fabric is an improvement just across the board. I think most of all, it's an improvement just in terms of the overall comfort of the device. When you actually hold it in your hands, it's way more comfortable. It actually feels more like a piece of clothing than a virtual reality headset. And then bringing it onto your face, we actually have fabric on the inside too, which gives you this incredibly soft feel rather than sort of bumping up against any plastic. If your nose is touching anything, it's just touching this soft fabric here. So overall, the breathability as well is significantly improved. And it's just, again, a much more comfortable device than we've ever built before.
Are you thinking about active cooling in there for defogging?
Not so much. That's a lot to pack into this unit.
Palmer did mention that the inside, the faceplate will be swappable for different heads, basically. How does that work?
So we have this facial interface here is actually going to be removable in the final version. I think actually this version is removable too, but I'm not going to pop it out right now. And that's going to allow for a couple different facial structures to have a more comfortable fit. Basically what we decided is that one facial interface, the ergonomics for that, wasn't going to be a great experience for everyone. And so we really wanted to try to come up with one or two swappable inserts that fits everyone. On the flip side of that, just one more added bonus to that is that if you use your Rift every day for 8 hours a day, after a week, if you want, you can pop out the insert, put in a new one. You get to replace that soft foam, which is obviously going to have some wear and tear to it.
So you're comfortable, like over the use of this, the wear and tear will be reasonable.
Oh, absolutely. Yeah, absolutely. But we also want, this is the part that's going to be resting on your brow. We want you to be able to swap it out anytime and have a new, soft foam there.
Curious, where's the microphone?
The microphone is in here. We're not talking about the placement here today.
So it's got to be something special.
I mean, it's actually not anything special. But we have it in the device. It's actually behind the fabric.
Got it. Interesting. Positional tracking. You're calling your system Constellation now, which is a brilliant name. Really love that idea because you're using the IR LEDs, which are hidden behind the fabric on the front and the back. Now the camera looks a little different. It's not your standard off-the-shelf camera. Can you talk about how positional tracking works with the headset?
So we actually have a sensor right there. You can see it actually, and the sensor is tracking this this constellation of IR LEDs that are embedded in the headset, like you just mentioned. So we have IR LEDs all throughout the shell of the headset, as well as on the back. And because of that, our sensor, which is basically, like you said, a custom camera, can track the position of these very, very precisely, very, very low latency. And it's actually the same tracking system. We built the tracking system from the ground up for virtual reality, designed around VR's constraints and requirements, low latency being really at the crux of that, but precision being really important too. And we've actually used the same tracking system to enable Oculus Touch.
Got it. And so you can put it on different devices as well.
Exactly.
How many LEDs? I mean, I assume they flicker and the camera system can recognize them. What's the arrangement configuration that the camera needs to see to be able to get a good positional tracking?
I actually don't know the number of IR LEDs off the top of my head, but what we've iterated on it a lot to basically have the minimal number of LEDs. It's sort of this balance between having a really robust experience and having the whole thing covered in LEDs, right?
Yeah.
But we have the sort of the perfect number for this industrial design, where we can track no matter what angle you're at, even if you're turning here where you think the coverage of the LEDs wouldn't be substantial, we can still have enough coverage to really track and then transition to back of the head.
And it's also combining with IMU data.
Of course, and that helps with overall latency of the device, because as people move very, very quickly, even if we can't track the IR LEDs for a moment as they sort of smear across the camera, we still have that IMU data, using our custom Oculus tracker inside the device to track the orientation at all times.
And the IMU polling, I presume, is higher rate than the camera then.
It is. It's significantly higher. Yeah.
Also in tracking, because the camera has a conical view, anyone who's used DK2 and who's tried that demo can see the boundaries of that.
Yes.
With this system, is there optimal distance? Like I assume far away, the IR isn't going to be as responsive as at an optimal distance.
We've actually designed it for basically sitting at your desk, or even almost this distance here. You can see it's about 3 meters, give or take. Giving people enough space that they can actually sit comfortably back from the experience, but also, lean forward, lean back. It's not designed really for your living room. Would it work in your living room? Maybe. Depends on lighting conditions and sort of the distance from you and your TV. Mm-hmm. But the optimal sort of setup that we are imagining is you set the sensor down just right on your desk, you put the headset on, you grab your controller, and you're done. And we really want it to be that simple, and we think that's an experience and sort of a setup that most gamers out there, when they get the Rift in Q1, are going to have.
And then you would want to reposition that possibly and reset up for standing?
Absolutely. It's actually the type of thing where you can actually just tilt the camera up a little bit. So if you see, we have the camera angled down there. So you can actually just change the orientation, and you'll get a much, you can just really just stand up. And I think it's one interesting thing is what developers are doing to try to sort of give you indication of whether the experience is seated or standing down. Because what we've seen some of the developers start to do is be like, hey, like as you're starting the game, just to note, this game is standing, so make sure you stand up and like change the position of your camera if necessary.
Have you guys ever experimented with multiple cameras?
We have experimented with multiple cameras. So the constellation tracking system that we've developed is absolutely supports and is capable of using multiple sensors. You're actually going to try in just a minute. The Oculus Touch demo actually uses multiple sensors that we've mounted there for a little bit more range and a little bit higher quality tracking.
And also helps with occlusion and blocking of the sensor.
Exactly. So yeah, if you turn all the way, there's still again a wider range of coverage no matter where you are with Oculus Touch. So with the consumer Rift, we're going to be shipping one sensor in the box. We think that's sort of the optimal, great user experience for folks, and we'll see what happens next.
Interesting answer. Now, obviously, Oculus Home, that software,
Yes.
that's kind of your baby. You've been working on interface. Now, it's really cool because you're sitting in like a virtual representation of a physical location, but the dashboard, it's kind of like your standard, 2D dashboard.
Yes.
Why did you guys end up there?
So we, after a lot of experimentation and design, we really focused on just the core tenets of Oculus Home being simplicity, real ease of use, and really just making it incredibly fast and efficient to get to your games and your content or your friends or whatever action you want to perform. We want to make it as easy as possible. So rather than having you sort of, some people imagine like, hey, am I going to be running through like a house, going through different doors to like find my games? What we found is, when most users throw the Rift on, they want to quickly launch a game or they want to quickly see what's new in the store. And bringing a 2D interface into VR, having that be sort of your portal to the platform and let you quickly jump to different pieces of content or whatever it is really the best way forward. And then I think you're going to see we're mixing in some really interesting VR magic into the experience. You can imagine being able to close that dashboard and look around your space and some of the things that can happen there. And we're going to see Home evolve a lot in the coming years. We have a lot of big plans. Right now, it's about giving you bringing all your Oculus and Rift games together in one place, connecting you with your friends, and putting as little as possible between you and the games you love.
And there's also a desktop version, desktop client, if you want to launch your game, tap in your friends list, and then put on the headset.
Exactly, yeah. If you want to, for example, buy a game, walk, make a sandwich, come back, throw on the Rift, and then jump in, you can do that all from your desktop. What we found, though, is once you're in the Rift, a lot of times you're like, okay, I'm done playing this game, or I want to see, what's Norm playing? I need a way to quickly jump to that content without taking the headset off, and that's sort of where the magic of Oculus Home falls.
Do you imagine that will move also to Gear VR, because you guys have iterated there?
So we actually have an early version of Oculus Home, sort of a very similar sort of parallel on Gear VR, and and yeah, you're going to see those feature sets aligned in a big way.
You see that the Wi-Fi bar and battery on top in the screenshots.
Yes, so we want Oculus Home to be a portal that you can drop into and have all your information there. So if you want to play for a really long time, it's no problem. So we have things like Bluetooth and Wi-Fi and battery and some of those things in there. But yeah, we're sharing a lot of the components with Gear VR, and you're going to see the two evolve in very similar functionality. We can do a lot more on the PC side, sort of like the environment that we're showing here today. And you're going to see more and more of that on both, really, but especially on the Rift because we just have more horsepower.
One last thing with Gear VR before we get to input, because I know everyone's excited about that. This is Q1 next year. Do you imagine, in your mind, is the platform launching with possibly the next node against Gear VR? Nothing you guys have announced yet, but what's the roadmap in your head?
For Gear VR?
For Gear VR and for launching Oculus Home.
Oh, so Oculus Home is going to launch. We kind of see it at the mobile track and the PC track. It's a Rift and the mobile track. So on mobile, Home's out there today. You can use it. It's a lot thinner, I would say, the overall user experience. But in terms of buying games, launching games, you can see all that magic sort of working on Gear VR today. And we're going to be launching that with the Rift in Q1 2016. When you get your Rift, you put on the device, you'll drop right into Oculus Home automatically. On the what was the next one?
On the Gear VR side,
Gear VR
end
side.
of this.
Yes. So consumer Gear VR is coming in a big way. Right now, we're sort of all in focused on the S6, which has a ton of great new content that we've been launching over the past few months. We've got more great content coming this fall. In fact, some of it's playable here at the show. And so if you haven't tried Gear VR and you have an S6 or a Note 4, I definitely recommend going and grabbing one. It's awesome. And we're going to be talking more about the consumer launch and what that means for gamers everywhere later this year.
Awesome. Thank you so much, Nate. It's awesome to see the Rift finally in person and actually hold it and wear it. We're now going to go try that Oculus Touch demo, the controller, the input solution. Thanks so much.
Absolutely.
So, Palmer Luckey, Palmer, your pet project finally revealed, Oculus Touch.
Yeah, we've been working on Oculus Touch for a couple years now, actually, and it has been kind of my pet project, but there's been so many other people working on this. I can't possibly take credit for that, but it's one of my favorite projects we've been working on. We've been working on it since actually around DK1 days. We've started experimenting with VR input. We worked with Carbon Design for a long time, actually before we acquired them, on making Oculus Touch, and that was one of the reasons they came on board. And our goal was to make a VR input system that makes it feel like your virtual hands are your real hands, that allows you to forget that you're manipulating using a tool.
And it tracks more than just position, because each additional point of that positional tracking, whether it's your hand, your wrist, but also the abstraction of your fingers, enhances, multiplies this feeling of presence. How do you get the finger tracking? You can do thumbs up, you can do pointing, you can grab things.
So, those are the interactions that you can do in this demo. The sensors are capable of a bit more, but the idea is that we didn't want to make a tool that you use in VR. We didn't just want to make something that you track in 3D space, track the orientation and position of. We wanted it to feel like it was your hand. So we wanted to be able to, in addition to tracking where they are, be able to do things like flick things off of a table. Like you saw me flicking things, off into space. We wanted to be able to point at things. We wanted to be able to give a thumbs up. We want to be able to do other interactions that may be considered obscene. Like those types of things you want to do with your fingers that you just can't do with any other type of controller, to my knowledge.
Some of that is actually positionally tracked because you have IR LEDs on there.
Yes.
So like the rotation, the wrist.
Yeah, the orientation and position of the controllers is tracked using our constellation tracking system, just like the headset itself.
And so how's a thumb? How does it know? Because it seems like a binary movement. It's not, every angle. It's up or down.
So I can't talk about the specifics too much, but it's not necessarily a binary sensor. It's set up this way in the demo. It was, when it just goes through the animation. We'd rather under promise and over deliver than show something that has to be turned back. And it's difficult to make controllers like this because everyone's hands are different. Different hand sizes, different finger sizes, different thickness of fingers. Making a controller that works for everybody with either no or easy calibration is pretty difficult.
I've noticed there are two cameras here. That's something Nate mentioned, that the constellation tracking system can scale.
Yes.
How are the two sensors? Is this used for purely compensating for occlusion?
Occlusion is the main thing. The camera that's shipping with the Oculus Rift, it's basically the same one as this one. It's technically almost identical. It's a very wide camera, and it can track a large space. Like, in fact, if you cover one of those cameras, you can track a very large volume.
Wider than what people experience with DK2, that grid?
Much wider. But what you're really getting is occlusion resistance. If you only have one camera, like if what happens if you're facing towards the camera and pull the slingshot while you're facing towards it? It can't see the hand that's pulling the slingshot back. And so by having two cameras, we've made it so that at almost any angle, even when you're facing away from one of the cameras, they're far enough spaced apart that it should almost always be able to see what you're doing from at least one of the cameras. It's largely for occlusion resistance.
You guys mentioned low mental load, the idea that you don't want the person to think or even realize they're holding controllers. It's just how their natural resting position of the hand.
Exactly.
How does that inform the type of interactions and game demos that you guys have experimented with?
Well, I mean, Toybox isn't a game as much as it is an internal test bed. It's like something we've used to develop all types of different interactions. And when you're doing that, it's not like a game where you're designing abstract interactions. You're kind of like Toybox, you tried it. It's mostly things you could do in real life. Like being able to take a lighter and open it and light something in the same way. Designing natural interactions, it's really as simple as designing things to be done in the way you would do them in the real world and designing controllers that let you do it that way.
And also informs how you represent the player, because it's a multiplayer experience. Right. You're only rendering, for example, just the hand, not the elbows or anything, because that's not something that's tracked.
That's right. There's some interesting compromises to be made in multiplayer environments. For example, you can do inverse kinematics off of the hand, and you can have a generally good idea of what the rest of your body is doing. It turns out our body's a very efficient machine. Generally, if I reach out and touch something or am moving something around, it does it in the most efficient way possible. And the most efficient way is actually the same for every person. Like the way I move my elbow about, it's often the same. Now there's things like, archery where it's not going to be always exactly right. But in this demo, we're just showing the hands themselves because we didn't want to get into the potentially uncanny valley of doing something. What's weird about multiplayer experiences is that you actually notice your own inverse kinematics being wrong more than the other person. So imagine that I'm doing something in a weird way. Like I choose to hold something like this. I'm going to notice that if I look at myself. Whereas if I see someone else's representation using inverse kinematics, and in real life they're holding it like this, but in the game they're doing this, and it shows their elbow like that, I don't know what their elbow is doing, so it's actually much more believable. So we're representing it like this because currently it's the most reliable way to show something that is absolutely one-to-one for yourself.
That's a really interesting concept, this uncanny valley of presence, and you've experimented with the thresholds of what's believable. And because some of it's abstracted, some of it's precisely tracked, and so that's something that you're ongoingly tracked. What are the things that really surprised you? I think John Carmack talked about eyes, for example, don't need to be perfectly.
Well, it's not even that they don't need to work perfectly. They don't even need to be accurate. There's a difference between using eye tracking for your own eyes and using it to make other people believable. If you don't have to have eye tracking be perfect, it just needs to be plausible. For example, if I'm looking at you and we think that I'm looking over here, and then we do some artificial things like artificial blinking, or I look over to another person that's nearby occasionally. Unless you're narrating what you're doing, like I'm looking over here, now I'm looking back, I'm looking over here, to people looking at you, it appears to be natural. So you can actually get away with a lot in terms of making other players appear to be more realistic than you can do in modifying your own presence in the environment. And there's interesting trade-offs with that.
Also for mental load, weight, because these things are light, they're wireless.
They're very lightweight.
Are you packing a battery in? Is it supposed to be a long use time? Like, what is the trade-off there? Because batteries can be heavy.
Yeah, so they are. We're not saying exactly how long you can use them, but you can use them for very long play sessions. They only have one battery in them, and we're actually using a voltage booster to run everything off that because it was critical that we get the weight down as much as we can. A lot of people have picked them up. They say, wow, like they kind of feel cheap. But if you actually flex them, they're really well built. They're really reinforced inside. People associate lightness with cheapness. not in this case. You want to make trade-offs to make this the lightest possible controller, because otherwise you can't forget that it's in your hand. You have to strain too much. You have to grip it too hard. You aren't able to kind of just let it float in your hands even when your hands are relaxed. So everything in that controller has been designed to be as light as possible.
Now, what about from developers' perspective? Are you going to want to get these in developers' hands? Is that one of the reasons why this isn't going to ship with the first consumer Rift?
So we are starting to, get these in developers' hands. Actually, right now. People have been working on this stuff in the past too. Where developers have been working on Touch for quite some time. In terms of bundling a gamepad with the Rift, one of the reasons we did that is because all the games that we've been working with on developers, and actually a lot of external developers that we have no financial interest in at all, they've been saying, we've been developing this game. We want everyone to be able to play our game without buying extra hardware. And so by bundling a gamepad, which isn't a significant additional cost, we can make sure that every person who buys the Rift will be able to play all of these games that are going to come out at launch and then later in the pipeline. And it's taken a long time for people to make games that work really well for gamepads in virtual reality. In the same way, it's going to take time to do the same thing for Touch. It might even take longer because people have never really had large-scale access to 6 degree of freedom motion controllers for VR. Whereas gamepads, there's decades of optimization around certain playstyles and genres that people already know how it works. We want to make them available right as soon as we can. That's why they're shipping soon after the Rift. That's why we're opening up pre-orders at the same time as the Rift. And that's why we're investing in content to make sure that there's cool things that people will be able to play in them. But we didn't think it was the right solution to bundle and we didn't think it was the right default solution at this stage in the game for what we are shipping and what our partners are shipping and what all the developers we've been working with are making.
VR is going to iterate quickly. Now, you mentioned gamepads. Microsoft, PlayStation, they're different gamepads, but there's parity. Do you feel like VR needs parity for some type of input or across hardwares to make it easier for developers to develop for multiple platforms?
Someday, yes, absolutely. But today is not that day. What you have with standards is standards are good in some ways, especially for certain types of developers, but they make it harder to push the limits and to innovate and to try totally new things. And in a way, they often spur a race to the bottom towards a common denominator of features. You probably saw the PlayStation Move leak. They've said that was fake. It was some design studio trying to attention whore. But if you can look at the feature set there was no analog stick. There were just 2 buttons and 2 triggers. Let's pretend that was the feature set for Morpheus. Lots of devs are going to be making games for Morpheus. If you set a standard that makes it easier to develop, that means that all VR games across all these different VR inputs are going to go to that lowest common denominator. They're not going to be able to take advantage of extra features, or at least they're not going to make their game reliant on those features, and they're not going to be able to push things as far as they would otherwise. I think it's way too early to start standardizing around any VR input because there's no way that we know that this is the best way to do things. And certainly it's too early to say this is the way that VR games are going to be locked in for years, because backwards compatibility is another thing. If you have standards that are across the industry and you try to maintain backwards compatibility, you're in an even bigger nightmare, because now you may have incredible innovations, but if you want to fundamentally change the controllers in a way that makes so you can't play the old games, what are you going to do? Are you going to also ship a totally old set of controllers? I'm talking about gamepads, but if there's a massive evolutions between generations, these are big problems for input, and I think it is too early to try and get developers to standardize. There will be games that are across all of these, but I don't think that it's a universally good thing.
I want to point and give thumbs up in games, and I know you've been thinking about it for a long time. Thank you so much, Palmer,
Thank you, man.
for giving us
It was
this
great
demo.
playing with you.
Awesome.
Norm.
That was pretty impressive. I think it was so cool. It's when we came out of GDC, we tried the HTC Vive, seen VR stuff, and we said that blew us away. And I love the Oculus isn't just catching up. They've been working on stuff for a long time, and it's just constantly leapfrogging.
Well, so the first thing I realized when I put on the CV1 is that they made another graphics improvement, another latency improvement. Something's changed since the last prototypes we've seen, and it seemed all of those little problems, like the edges not quite aligning right, and your eyes thinking that they're slightly out of focus or something like that, they don't have those problems with this. The other thing I noticed immediately, super duper light.
Yeah, this is it's tough to give you a sense of exactly the weight of this, but it's a little heavier than a baseball cap. There are 2 screens in here, there are electronics in here, the microphone's hidden in there, but it is surprisingly light, and it did not feel like it was difficult to wear for a long period of time.
I mean, it hooks on the back of your head, and it feels like most of the weight is literally right on the top of your head in the kind of bald spot area.
Right.
The other thing I noticed was the sound is these headphones. I mean, they look like the kind of cheap headphones that you got with a Walkman 20 years ago. They sound really, really nice in person, and they're really good at blocking out all the sound around you for on-ear headphones, especially. Like, you know, you were talking directly 3 feet to my left, and I was in some sort of demo. Couldn't hear you at all.
Yeah, Nate did talk about how these specs compare to Crescent Bay, which is the last prototype we used. This foam and the lenses have a better sweet spot, I think, is what we want to get across. And the sweet spot means that when you're looking at the center, that's when the image is most clear. With Fresnel lenses, they're thick. You look to the edge on the old ones, and they could get blurry. You're losing data.
Or if you had the glasses just off-center just a little
Exactly.
bit. The sweet spot on these, I went from this straight to Crescent Bay, and the sweet spot on these lenses seemed to be much more forgiving than on the other ones. I don't know that it was better. I don't know if the optics are better, but in terms of getting it lined up right and not having fuzzy, kind of blurry out of focus vision, much better experience with the CV1 than the Crescent Bay.
This fabric, don't worry, this feels solid. Doesn't feel like it's gonna wear. And the fabric on the inside is actually different. That's actually stretchier.
It's like mushy foam.
And I'll be able to show you, here they actually have the IPD. I can actually...
I think this is a non-functioning prototype, we should mention. There's no screen inside there.
Exactly. See the IPD? That's...
It's adjusting. So a couple of things I talked about with Nate while you were doing the toy box demo later on. The foam and the cloth, it's not going to be replaceable. So they're working on coatings and like industrial design stuff to make sure that this is something you can wipe clean or that will stay clean and will not get funky and crufty like the inside of a baseball cap over time when you use this.
Now, also positional tracking. So constellation tracking, this is supposedly have a much better field of view camera than the DK2. In the DK2 demo, if you turn on that wireframe, it was like the triangle went like this.
Yeah,
if you move out of that, you lose positional tracking.
Exactly.
Here, while we didn't get to see that wireframe, one of those was supposedly wide enough to map the entire room.
When I was sitting in the chair, I was able to rock as far as I could in the chair, like without falling out of the seat, without losing tracking at all.
Another
so
interesting
that stuff was
thing.
really good.
For standing, you just tilt it up. That's
nice.
cool. Yeah, you tilt that up for standing and sitting. And that will require USB 3 because it's not just sending numbers.
Yeah, so we're talking about two USB 3 ports, a USB 2 port for the dongle for the Xbox One controller. Xbox One controller wireless is only wireless on Windows 10 right now.
Right.
That may change, but that's kind of on Microsoft, not Oculus.
Yep.
However, you will be able to just plug it in with the micro USB cable to your computer, just like you can today on Windows 7 and Windows 8.1.
Yep. The games we saw. We got to talk about the games. I think we both tried the Insomniac game.
It's Edge of Nowhere.
Edge of Nowhere. That one was a third-person adventure game. It's really interesting to see how developers are using the glasses,
how camera control works.
Exactly.
Like if you think back to Mario 64, when they figured out camera control by putting it on the C buttons on that weird N64 controller, that was a real turning point. Even though that camera is super janky by today's standards, it made 3D platforms possible. They're still figuring out, like developers are still figuring out how the cameras should work in these games.
Chronos, which is another third-person action game made by the people who developed Hero Bound, fixed camera. Every time you enter a room in the dungeon, your camera's fixed in one corner.
It's
pre-programmed.
They pick the corner that you're going to be in for that room.
And then your head looks around that. With Edge of Nowhere, the camera's following the player.
It's almost like it's on a rail that goes along the path of the critical path of the game.
But didn't do any crazy swings. And one of the greatest parts of that demo is you're walking and your camera's behind the person, you jump onto a rope, and then the bottom falls out, and that's when you get to look down. And
looking down always is, I'm scared of heights, looking down always is exciting and scary, and I meant to track my heart rate while I was doing that. I feel like probably I spiked up to 120, 140 beats per second when I was looking down, beats per minute when I was looking down and could see basically infinite space beneath me.
What about the VR sports demo?
So I did the VR hockey demo, which basically you're a goaltender in a hockey game, and there were two things going on. One is that you have to track the puck by watching it, keeping it in the center of your field of view. They were indicating your tracking by giving you a kind of a green, like that, the Fox hockey glow around the puck. If it was green, you were watching it. Then when they would fire it at you, you had to either hit the right bumper or the left bumper on the Xbox One controller to block left or to block right. seems really simple. The puck was coming at what I assume was full speed. It was terrifyingly fast, and it, like, for the first time in my life, I have a real appreciation for what it takes to be a goalkeeper. I was a terrible, terrible goalkeeper, but it was super fun to put myself against that. Like, the other players were hitting around. One of the things you never appreciate playing those isometric overhead hockey games like NHL, the NHL series from EA, is that when there's a bunch of guys between you and the puck gets lost in between their legs. That you can't lose it, you find it, you have to pick it back up again, it turns green, you know you're tracking again, and then still when they fire, you have to decide, okay, are they going right side or left side? It's a grossly simplified compared to real hockey, but what I really wanted to do was throw my arms out to catch those pucks.
And that's a perfect segue to talk about the input controllers, and these are the Half Moon prototypes, Oculus Touch, which won't be shipping with the Oculus Rift in Q1, but will be available for pre-order at the same time, and will ship shortly after.
First half.
First half, first half of 2016.
Okay, so there's one thing, we've talked about this a lot, there's 2 buttons on each controller, a stick, and then there's a trigger, and then also a button for your middle finger. The thing that they didn't touch on in that press conference last week is that there's capacitive touch on both the top of the thumbstick and the index finger trigger. So the controller knows when your finger is on the trigger, and that lets you do things with your hands, like thumbs ups and pointing. Or pointing with the thumbs up to make a gun.
Positional tracking for this one works a couple of ways. You see these IR LEDs on top, and so when I'm moving around, this ring around lets the cameras, 2 cameras or maybe more in the future, track where I am. So even if I'm turning this way, another camera can see where this is. That's wrist positional tracking and arm positional tracking.
And I think they're probably doing inverse kinematics on that because they know where your hand is.
Yes.
They can model your skeleton. Modeling an arm is relatively simple. So you had a good sense, at least in the thing that we saw, you had like the forearm and the wrist.
You just
basically.
had the wrist. Just had the
Oh,
wrist.
it was just the wrist?
They didn't
I thought
want to
there
do the
was
forearm. I talked to
Okay.
Palmer about it. They did not want to give you the forearm.
My brain filled in the forearm.
Yep, exactly. But for the tracking of your fingers and thumbs to simulate, to tell where the thumbs up is, that's abstracted. Like, it doesn't know exactly that my thumb is, right here or right here, but it knows if I take my thumb up like that, it will just switch.
It's off the thumbstick, not
It's
the
off the
buttons.
thumbstick.
Yeah.
Then it knows I'm doing a thumbs up.
So the experience that they had us in for that is called the Toy Box, which is their kind of test environment for prototyping different controllers. It's a place that they can pick things up. You could toss something from one hand to another. Like the control that you get with the middle finger button
Grabbing.
and the grabber, we'll call those the grabbing buttons from now on. It lets you basically, when you push the grabbing button, that gives you collision detection on your hands.
Yep.
At which point you can interact with the world around you. If you want to pick something up, you grab it with the collision button and then trigger.
A little bit of a learning curve with that. It took me like 15 seconds just because when I want to grab something, I'm grabbing it normally, like this. And I'm using multiple fingers, I'm pinching like that. If I'm grabbing in the game, it's more like a hand grab, like holding something. So I'm like grabbing like that.
That was a layer of abstraction that for me took a couple minutes to get over to the point that I didn't have to actively think about it. And by the end of the demo, it was completely without thought. That interview was 10 minutes long probably. So after 10 minutes, I felt very comfortable in the same way that I did with the Valve stuff that we saw at GDC.
Now they're very aware of keeping these light. They said that with the battery, you'll be able to use it. They didn't say how long, but it'll be a long time. You're not going to have to switch it out a lot.
Is it inductive charging, or did they say?
They did not say anything about that, confirm anything about that. They did say that, in that demo, it was also, we got to talk about it being a multiplayer experience.
Yeah.
Someone was in a different room using this, and you can communicate. Now, you got to imagine, in the real world, it could be someone across the country, across the world, and you're interacting with them, with their avatar, and you can be at different scales.
Here's the thing, when they're talking, their lips aren't moving, but there's kind of a shimmer on the polygon mesh that's in the world. When they're waving their hands, you can pass something to the virtual person in the world. Yeah. When he's standing in front of me, I would hear his voice from ahead of me. When he was standing to the right, I would hear him from the right. It felt, after 5 minutes, it felt like Chris was there with me, and we were passing things back and forth and kind of tossing and throwing things at each other, shooting each other.
I picked up a Roman candle, and he lit it with a lighter from across the table. It was
super, super compelling experience for something that's really, really simple.
I think the communication, that social aspect. Imagine juggling back and forth between someone. I tried to juggle myself.
I couldn't juggle.
Couldn't catch them in the midair. but they can change whatever that toy box experience
I
is.
did almost smash the prototype controllers together when I had two things in my hand. And I wanted to see what happened when I smashed them.
Yeah.
They had. Did you do the bit with the ray guns?
Yep.
So
Shooting the ray
you pick up
guns.
2 ray guns, and it's just pew 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 pew. It's awesome, super fun.
You can look down the barrel, doing boxing gloves, robot gloves.
Oh, I didn't get to do the
it's a
boxing
very
gloves.
natural action, just to box
Picked
in
up a
midair.
puppet and could
Yeah.
puppeteer with the trigger,
Slingshot.
the thumbsticks, flicking the lighter with the thumbstick. Super real.
Yeah.
Like those experiences, once you abstract the grabbing and finger control, a whole lot of stuff becomes possible. And you can even do things like take your finger off of the trigger and close the grip to make your collision stuff turn on, and then push something across the surface just like you would in the real world.
Exactly.
It's pretty amazing.
I mean, we've used HTC Vive, which has similar controls, grabbing controls, trigger controls, but it doesn't do the finger abstraction, the pointing, the thumbs up, and that kind of gestural stuff. It's going to be really important with multiplayer, which is something also they haven't shown on the CVR side.
I mean, one of the things that Mark Zuckerberg talked about when he talked about the Oculus acquisition is that they were interested in using this for communication. I'm much more interested in the possibility of this toy box type metaphor for communication than I am in a virtual wall or whatever your Facebook joke was a year and a half ago. It was really compelling in a way that's difficult for us to convey here. I would totally go back and I would have spent another half hour just noodling around with somebody in the virtual environment. It's super fun.
Yeah, so that's exciting. We got our hands on with not only the CV1, their latest manufacturing almost prototype. They're going to do some tweaks to it, but the closest we've got to consumer version and also Oculus Touch.
Standing, sitting, real life hands,
Games.
the whole thing. I cannot wait until next spring.
Yeah, so we'll have more stuff, of course, from VR from E3 2015 on Tesla.com. Subscribe to our YouTube channel, post your questions below, and like this video. We'll
See you guys
next
later.
time.